Hi there, and welcome to something a little different today. I'm going to be talking about my new Starlink dish and my Starlink service that I got a few days ago. I set it up myself, and I'm going to be covering some things that I couldn't really find myself before I was purchasing the Starlink, so I hope this will help some people. We have some avid gamers and streamers in the house, and I didn't know how it was going to work, and went online to search some things and I wasn't able to find it. Some of this information that I'm going to cover, so I'm hoping this will help all of you guys. As you can see right there, say hello to my little friend. That's the standard residential dish there, and obviously I'm up on the roof to show it to you. The way I mounted mine, I'm not going to go into detail about that, but you can probably see it in the background there. I decided not to take any of the tiles off of the roof. I just got some construction adhesive and put it on a couple 2x2s and glued it securely to the tiles there, and I secured a bunch of the tiles around it. And that's plenty strong enough to hold it, even in pretty severe thunderstorms. Now, I would take this down if we're going to get a hurricane. That's the good thing about hurricanes, is you typically know when they're coming. Just 5 minutes to come up here and basically undo the set screw on the side there and pull the mast up, turn it over, click the little slide that connects to the dish and unplug the Ethernet cable. It's like 5 minutes, and I just take it inside until after any bad weather is done from a hurricane or something like that, then bring it back up after everything clears so that we'll have internet. So you can see the wire right there. It's going into one of these vents on the roof. That's just a heat vent, and it was pretty easy to run the wire through there and crawl around in the attic and hook the Ethernet cable up in my office. It comes with 50 feet of cable, which was enough to get it over to the office on the other side of the house, because in the attic you can go diagonally, so it's pretty efficient. So let me go in the house and boot up the computer, and I'll show you a few things about what I did to hook this system up, talk about it a little bit, and specifically how it works for low latency gaming and online streaming, meaning streaming out if you're doing a live stream. So let me get down off the roof and I'll go in the house and we'll pick it up from there. It's kind of cool up here, being up here and being able to see around the neighborhood from up on the roof. It's pretty nice. This time of year anyway. One concern I have, and I don't know the answer to this, is this dish is supposed to be good to 122 degrees Fahrenheit. And on this tile roof, even though it's about a foot from the surface of the tile here, I suspect in some of the 95-degree days that we get here, it might get to 122 and go into thermal shutdown. But it's almost March, so obviously it's not that hot right now. So I'll have to see how it does on that and report back later on that situation. But I haven't heard of too many problems online. Maybe it won't get, since it's out in the air and out in the open, maybe it won't get to 122, because the max it ever gets around here is like 96, 97. So maybe, probably would be close to 122 on the dish, but maybe there'd be enough ambient cooling to keep it under that. We'll have to see on that front. So, all right, here we are inside, and the first question a lot of people have would be, why get Starlink when we have Spectrum cable internet? We have broadband over cable now, and our service is the highest you can get here on Spectrum, which is gig by 35, which means 1 gig down and 35 megabits per second up. It's pretty slow upload speed, but we don't have high split here in this area, and even though Spectrum has been promising it for half a year, I don't expect it anytime soon, because most of Spectrum's promises are empty promises. So let me go ahead and answer that right now, and of course I'm going to use QImage here to look at some of these thumbnails that I've captured for this video. We have two people here who live stream. They're Twitch streamers, and they need to play low latency online games. So this is a typical day with Spectrum. You can see the ping. I'm using ping plotter here, And the latency graph here, as you can see, it's pretty good up until about 9:40 a.m. and this was today. This is a typical day. And then at some point between 9 and 10 in the morning, it usually does this. It goes down the drain. And we've got high spikes here, a lot of lag, a lot of higher latency. And if you try to live stream on this, good luck. You're going to just be doing nothing but buffering and freezing. And if you're trying to play an online game, which, you know, some of these people in the house here are Twitch streaming online games, you're going to be rubber banding all over the map and have lots of issues. And then, like typical Spectrum, it'll go back down and it'll be okay for 10 or 15 minutes. And then, as you can see, it's coming back up here too, and it'll do this again for another hour, hour and a half. So we've been having problems with Spectrum since, I don't know when the switch over. Bright House Networks is what we used to have, and they were great. As soon as Spectrum took over, we've had nothing but problems with our internet here. And I don't know if it's oversold bandwidth or just improper maintenance of equipment, because every time Spectrum comes out, they'll open up a amplifier box or something like that. And, you know, we have like 20-year-old taps that they've never replaced in the neighborhood, but that's another story. Their maintenance, when they come out and work on something, they leave the box half open, cables laying out in the grass where landscapers could run over them by accident. So that's the kind of work that they do. And I've filed FCC complaints. I've filed 3 FCC complaints already. And they'll come out and take 2 or 3 weeks of my time, you know, messing around trying to get this fixed. And they'll finally get it down to looking like this on the left side here for a whole day. And they'll be in a hurry to close that out. Oh, we got to close this FCC complaint. And I'll say, okay, well, today it looks fine. They'll close it out, and 2 to 4 weeks later, it's back like this again. So I've given up. I'm not going to file any more FCC complaints because they don't care. So I finally gave up and got Starlink. And as you can see, this is a typical day on Starlink. Now, you do have an occasional individual spike here and there that's over 50 milliseconds. But for the most part, it's just like Spectrum. When Spectrum is good, Spectrum's a little bit under the 25 milliseconds here. And Starlink is about 25 to 35 milliseconds. So Starlink may add maybe 10 milliseconds, but it's consistent. You've got, like I said, an occasional spike above 50, but it's really good compared to this mess that we have up here with Spectrum. But what I want to do in this video is tell you how I got here, because when I first hooked up Starlink, I was getting, like, look at my cursor here, look to the left of the cursor here. I was getting kind of these. It wasn't as bad as Spectrum over here on the right side, but Starlink looked kind of like this in this range at first, and I was like, well, that's not a whole lot better than Spectrum. But I eventually got it down to this, and I'd like to show you how I did that. And some of this information is online. Some of the other information is not. So I want to cover that. And just for anybody that wants to use or try Starlink for this use, and I have played games, I've played Overwatch. My son's girlfriend played her Valorant games on Starlink, and you know, the ping was higher, but at least it was consistent. She wasn't rubber banding to a different map when she's playing it. So, and for me in Overwatch, I never even noticed that I was on satellite internet. It worked fine for something like Overwatch that has latency mitigation. Valorant is not as good at that. Any little glitch that you see in Valorant shows up because it's more sensitive to that. But the games that aren't as sensitive as Valorant, you're never going to even notice. You're going to think that you're on a wired internet because this ping is pretty good, especially for satellite. All right, let me get off of that little soapbox and come out here and show you. The first thing that I noticed, and I actually talked to support from Starlink, and you can chat with support online. They're really good, very responsive. I got like, you know, a half dozen responses in one day back and forth, and me replying to them, giving them information. But what I wanted to ask them is, when you go into the app, the first time you set up your Starlink, it shows you this in the app, and it gives you the tilt and the rotation, and you can spin this with your finger in the app and make sure that you're lined up here. And when you line it up with that, you think everything's great. And later I found on the Starlink website, they show you a diagnostic page. You can log into your Starlink. I have mine in bypass mode, my Starlink router in bypass mode, because I use a third-party router. That's part of how I got the ping way down. But I'm getting ahead of myself. You if you go to 192.168.100.1 and you can basically log into your dish. And again, I'm just going to call it a dish. I know it's an antenna. But you can log into the dish on the roof and it'll show you the actual alignment, what the dish wants and what it actually is. So what happens is if you set your dish by the app, and you can tell that this is not tilted right in the app. It's tilted a little bit too low. It needs to be tilted up a little. If you put it exactly the way it should be in the app, when you come here and go to the diagnostic page on the dish will say tilt recommendation, tilt down 8 or 9 degrees. So then you're scratching your head and say, okay, well, I'll align it to this. So I aligned it. You can see I'm within a half a degree in both rotation and tilt by the diagnostic screen on the dish. Again, it's 192.168.100.1. So if you align it nearly perfectly by this, you go back to the app and you get a little amber note on the front screen of the app like this. It says Starlink is misaligned by 9 degrees. And it'll show you like this. Sure enough, it wants you to move that dish up more by 9 degrees. And then if you move it up by 9 degrees, obviously the dish diagnostic is going to be misaligned. So they don't agree with each other. So my only message to Starlink support was, hey, you provide 2 tools here and they're both disagreeing with each other. What should I go by? What should I believe? Should I believe this one or this one? Because they're both telling me to use a different tilt. That rotation I think was pretty close. It's just the tilt. So I really couldn't get an answer from them, but what I did, I noticed something interesting. If you go into your obstructions in the app, and this is the obstruction map. I don't have any obstructions because actually you can see up on the roof like that, it's just clear sky up there. There's no trees or anything in the way. These little red dots here are just, they're not obstructions. Everybody gets those. It's, I don't know, it's like a plane was in the view or something when the satellite happened to go by. But this whole shell is blue, unobstructed view. But the interesting part is over on the northwest, we've got these empty areas on the map. And all this is the geometry of the satellites. And if you look at the globe, all 7,000 satellites, Starlink, they're all going in one of 2 directions, and they're kind of enveloping the Earth. And the mesh is moving. But just by the geometry of the satellites, no satellite happens to pass over this area right here. So you got a few dots here where, these are not obstructions. They'd be red if it was an obstruction. This is just no data. And no data means that just by the geometry of the satellites, no satellite moved across these particular really small areas. But that gave me an idea. I thought, okay, well, we've got some area here that's not being used, even though it's only a tiny bit. It's full up here on this side, so why don't I tilt the dish up a little bit, and then if I tilt the dish up, these areas would naturally move off the bottom here, and I'd get more up here. So I did a test. I moved the dish 15 degrees, because I wasn't trying to get things right. I was trying to see if this would work, if this area would move here. So I tilted this up by 15 degrees, thinking that would surely make these dots go off the bottom of the cone here. But what happened was, it was interesting. I moved it up 15 degrees and waited a day for this. I cleared the obstruction map, so this is all blank. And then, you see various lines crisscrossing through here as satellites pass through, and it builds this map over about a day. So I let it build it, and to my surprise, these areas right here were in the exact same spot in this cone of what the dish uses. So I finally realized that what's happening is the system is designed for you to take this dish and basically aim it in the basic direction, but the design of the dish, they can, phase array, they can move their cone. Like imagine a cone like this over the dish. So if you get the dish basically right, the dish is going to move that cone wherever it wants it anyway. So it really doesn't matter whether you go by the app or by this diagnostic page, because, I think this is proof of that. when this thing shows 9 degrees, when you get this to look right and you get the, make the app happy and you come back here and this says 9 degrees down, what that means is the dish itself is having to move the cone 9 degrees to be optimal. It has watched all the satellites and built that map, and it knows that it is using its phase array to, not mechanically but electronically, move that 100-degree cone that the dish can see on its own. It has to move it by 9 degrees. So what it's saying to you here, I believe, and again, this is all conjecture because Starlink, I asked them 4 times and they would not tell me how this actually worked. So we kind of have to guess, and I kind of have to go at this as what would I do as a software engineer. I would build the dish to have more than 100 degrees. It's advertised as 100 degrees of view of the sky. So I would build the dish to have 130 degrees, let's say. And I would just allow the customer to get it pretty close, and I would use my electronics in the dish to point that 100 degrees within the 130 that I have access to so that it's pointed exactly right. So I think that's what's happening. What I ended up doing was leaving it by this diagnostic page, that 192.168.100.1, because now the dish itself says, okay, my cone is perfectly aligned in the center of the dish. And I believe that'll give me the highest gain. That's why the dish wanted me to, if you set it by the app, the dish wanted a 9-degree difference because it was having to tilt its cone electronically 9 degrees. Now it's only having to tilt the cone electronically 0.31 degrees down and 0.15 degrees to the right, clockwise. So I think that's how I interpret this, and the difference between this diagnostic page, the web UI on the dish versus the app. I think the app, because this has to work before you even set the dish up, before it's finalized and before it's looked at any satellites, this has to work. Like when you're first putting it up on your roof or hanging it from a tree or whatever you're doing with it, it has to know. And I think this basically just goes by your GPS location and says, okay, based on where you are, we think you ought to put the dish here. And then over time, the dish actually does, observations, and it determines, no, I know that the app had you set it here, but it would be optimal if you moved it down 9 degrees. So that's what I did with that. And I think it seems to perform a little bit better if you do it if you align it by this. Not much, and it's probably negligible, but that's the story on that. The story on getting my latency like this is, I did a lot of research, and I'm wondering why my ping was a little bit higher than I had expected it. Like the ping would be low like this sometimes, but it would go up at other times. And I thought, well, it's probably just traffic. It's probably just network congestion. But it turns out that's not really the case. I saw a lot of recommendations on Reddit to get a router that supports QoS, quality of service, so that it can adjust your upload and download bandwidth to what is, doable without affecting your latency. And the problem with something like Starlink is your download bandwidth and upload bandwidth change all the time. You may run it one time and get 200. I've seen as high as 400 megabits on the download and as high as 45 on the upload. And other times, like if it's drizzling a little bit, I might see like 80, 90, 100 down and 9 or 10 up. And it's really hard to set your quality of service so that it doesn't affect your ping. It's called buffer bloat. If you don't want buffer bloat, which is, if you use up all your bandwidth, like if you set your quality of service to 100 down and 10 up, then you're not going to have access to the 20, 30, and 40 up when it's available. And conversely, if you set it to, like, say 30 up and 150 down, then somebody may be downloading a file and using all 150. And when that happens, you get buffer bloat. And when you're using up all your bandwidth, you'll see something that looks like this. Now, this is Spectrum, but I'm just using this as an example of what can happen. All of this on Spectrum was happening when we weren't even using the internet. This is all Spectrum's fault here. But if you allow buffer bloat to happen, if you don't use QoS on your Starlink, you can see areas that look like this, or even a little bit less if you're only coming close to and not going all the way up to the maximum bandwidth. So you have to use quality of service, and it's best to use a router that supports cake. And it's even better if you can use a router like I got the GL MT6000 router, which is an OpenWRT router that allows you to do a lot of customizations, and you can really geek out on settings on that router and install something called Cake Auto Rate. And the auto rate, what that does is it allows quality of service to work when your rate changes. So it'll actually figure out what your rate is at the current second and not let the rate get so close to the maximum of what you can achieve. And that removes almost all of the latency spikes in Starlink. And I end up with this, which is pretty good. This is pretty consistent. I'm not going to go into how I set all that up because it requires some GitHub knowledge and installing things and using VI editor and bash to edit files and things like that. It's probably out of the scope of what most people want, but if you guys want me to do a video on that to try to get it down to where the average person could probably do it given my instructions on that particular router, I could probably make a video doing that. Just let me know in the comments. But that's where we are right now. I'm really happy with the fact that we got really consistent latency. Now I want to mention one more thing before I go here. I know this video is already long, but this was meant to be a geek out video that has some information that is hard to find. What I noticed was this is already good in my eyes for satellite internet. 25 to 35 millisecond ping with an occasional spike over 50 here and there. But what I noticed is if you do anything, this is just pinging again, this is ping plotter, just pinging every second, pinging a reflector, which is just a website IP address. You can pick many different ones. So this is just pinging once every second, and nothing else is going on the network right here. I did this at a time when nothing's happening. If I bring up a browser window or something and I click on a live stream, which live streams aren't buffered, at least not really. You're kind of fed, unlike a YouTube video, which can buffer 10 seconds, 20 seconds at a time. A live stream typically is fed to you continuously, which means that there's some load on the Starlink network continuously. When you do that, the ping actually goes down, and you get like this area where I'm holding my mouse here. You get almost stable 25 millisecond ping. So I think Starlink, and again, this is me just guessing and using powers of deduction to try to figure out how this system works. But because the ping goes down even more and gets even more stable when you actually start using the network, that tells me that Starlink may be doing something smart where they're not going to give you high priority if all you're doing is pinging every second. You're not really using your network. I mean, nobody cares if a ping gets the absolute minimum. But as soon as you start doing something like playing an online game or watching a live stream live that has to be fed continuously, the ping gets even more consistent. So I think they're pretty smart, and they're actually making sure that that's one thing that can help not saturate their network is you don't need to give somebody who's doing nothing but pinging high priority. But as soon as they start actually doing something, then you give them a higher priority. And I've tested it more than a dozen times. I thought I was going crazy, like, is that ping really going down even more when I start watching this live stream? And then I'll stop and it'll go back like this. And then I'll start the live stream again and it'll be like this, really low. Then I'll stop and I'll see a few spikes. It's not that it's bad when there's no live stream. It's just that it gets even smoother when there's some network traffic going on, when you're doing something real. And that tells me that Starlink is probably trying to do some smart routing or smart priorities in their system. So anyway, that's a lot of nerding out on Starlink, and I'll stop there for this video. Hope this helps some people, and I hope all the information is right. Like I said, I've only had it, it's going on a week now, I guess. Maybe 5 or 6 days that I've had it, and I've been optimizing it each day, taking a couple hours here, a couple hours there, and finally got it to where I want it. So hopefully this helps, and thanks for watching.